Hi, this is Mike Lawless, the Philosopher Engineer. In this section, we'll focus on the technical and tactical. We want to have videos available that get into the details, into the math, into the engineering details and the process, where you can analyze and break down problems. This may be one of the more useful areas. We'll get a little bit technical. We're really focused on the specific steps that you can take to be proactive in the development of your products and understand reliability ahead of time, understand failure modes ahead of time. And it's common sense, but not often practiced. And part of the proactive really involves using the tools that have gotten better and better on computers. We really advocate not only simulations and math analysis, but what they call the digital twin. We'll talk about the digital twin, and that is really developing all the behaviors of the product in a virtual world. It becomes your code. So this is a really important step, especially on big projects with a lot of risk. And you can, what we call virtual prototyping, virtual testing, and then you can break everything virtually. You can obviously break it physically as well, but it's faster to break it virtually. And to understand the reliability of the product, we have to understand design margin. Well, the only way to really understand design margin is to actually break things. Now you can break it virtually, quickly, and then understand where your high risk areas are. It's all about de-risking the product as quickly as possible. So there's a parallel path between the virtual world and the physical world, very much like the CAD that we use. I'm old enough to have used an old drafting board and the old way, but nowadays with the advances in computers, you might as well take advantage of those tools. So we advocate an approach where you do the virtual prototyping and create a digital twin and use it. So we'll get into a lot of specifics about that in this section, which will be technical and tactical. Engineers are welcome. You don't have to be an engineer to participate here. I'll try to make it describe things in a language that could be understood, but we will get into how to apply the math, how to look at the functions and break them down, how to look at the whole product, the subsystems, each interface, and the component level, and how all those can be really wrestled to the ground, understood, and then de-risked as quickly as possible, which will help the product development go faster. You'll be less likely to miss a deadline or have an unexpected problem either in launch or in the field.